add a set of curly braces, and then within this array you can enter in some values. Pick some food that you like. I'll enter in a pizza, taco, and hamburger. The size of this array is 3 elements. Once you set a size for an array, normally you can't change it. This array will have 3 elements. However, all the elements are already filled with values. To create an empty array, you don't want a set of empty curly braces. Then we're creating an array of no elements. Just to demonstrate that, I'm going to print the length of our array foods. Foods.length. This is going to give us 0. And we can't assign any values. Even if I attempt to, let's say foods at index 0. What is going on, everybody? In this video, I'm going to show you how we can search through the elements of an array. Let's begin. We'll need an array to work with. To keep this simple, let's create an array of integers. We'll create an array of integers named numbers. Equals, make up some numbers to put within this array. I'll just type whatever comes to mind. Good enough. We'll also need a target. What number are we searching for? Let's say I'm searching for the number 2. I will create an integer variable of target, set it equal to 2. In data structures and algorithms, we'll be performing what is known as a linear search. We're going to use a for loop to iterate through these elements, and then see if there's a match. We'll create a for loop, create an index of I. I will equal 0. We'll continue as long as I is less than our array of numbers, access the length property. That will return the length as a number. Then increment I by 1. I will check using an if statement if our target is equal to our array at the current index of I. At first, I will be 0. And then we increment it during each cycle of this loop. If our target equals the current element, let's print the following. Let's say element found at index plus I. That's our index. In case we find the target, for example 2, we don't need to search through the rest of the array. We could add what is known as a break statement to break out of the loop. If we find the target, break out of the loop. Let's perform a test run. We're searching for the number 2, and we'll be given the index element found at index 2. Let's look for 1. 1, 2, the loop. Let's perform a test run. We're searching for the number 2, and we'll be given the index element found at index 2. Let's look for 1. 1 is found at index 0. 4, which is near the end, is found at index 6. 0, 1, 2, 3, 4, 5, 6. What if we don't find our target? I don't have the number 7 in here. Well, there's no output. Since this if statement is never true, once we reach the end of the array, we don't do anything. So let's add a Boolean variable of isFound and set it to be false. We'll check if isFound is false. If that is the case, we'll output a message that element wasn't found in the array. So if we do find our target, we'll take our Boolean variable of isFound and set it to be true. We have found our target that we're looking for. If we exit the for loop and never find our target, we can check that. We'll say isFound, but we'll use the not logical operator. The not logical operator gives you the inverse of a Boolean value or variable. If isFound is false, if something isn't true, if we don't find the target, then we execute this if statement, where we will print the following. Let's say something such as element not found in the array. All right, we are looking for the number 7, which does not exist within this array. That would give us this message, element not found in the array. Because isFound was false, we could never find it within this for loop. So we're checking if isFound is not true. What if we have an array of strings and we're searching for an element? Well, instead of using the comparison operator, we have to use the equals method of strings, because strings are a reference data type. So this time, let's say we have an array of strings named fruits. Think of some fruit. I will pick an apple, an orange, and a banana. The target this time will be a string. Let's say I'm searching for an orange. We'll iterate through our array of fruits. The condition for the for loop will be I is less than the length of our our array of fruits. Now we can't necessarily say, is our target equal to fruits at index of I? We're comparing two strings, and since strings are reference data types, we would end up comparing the memory addresses of two different strings. We would be saying, are these two memory addresses the same? Are they at the same location? Which isn't the case. If we're comparing the value of strings, we'll use the equals method. Let's take fruits at index of I. Call the built-in equals method of strings, and pass in our target as an argument. Now this should work. We are searching for an orange. Element found at index 1. Element found at index 1. What about a pineapple? Element not found in the array. There was no pineapple. Let's modify this program slightly. We'll accept some user input, but we'll need a scanner. Import the class, java.util.scanner, and close your scanner when you're done with it. Scanner.close. .util.scanner, and close your scanner when you're done with it. Scanner. .close. Instead of assigning our target, we'll accept user input. We'll use our scanner, use the next line method, and we will also need a prompt. Let's print the following. Enter a fruit to search for. Just to make this a little more clean, I'm going to move this variable of isFound to the top here. I'll declare our string of target, but not assign it. And then after the prompt, I'll assign our name of target. This is just how I like to arrange things. But it all works the same. Just to make this, enter a fruit to search for. Just to make this a little more clean, I'm going to move this variable of isFound to the top here. I'll declare our string of target. But not assign it. And then after the prompt, I'll assign our name of target. This is just how I like to arrange things. But it all works the same. Now we can search for an element after accepting user input. And I will convert this to be a print statement instead of print line. All right, let's search for some fruit. Is there a coconut? Element not found in the array. Perhaps a banana. Element found at index 2. 0, 1, 2. All right, everybody, so that's how to search through an array using Java.
Scribe is how you stop explaining the same thing over and over at work. Watch this. It'll change your life. Raise your hand if you've told your boss how to do the same thing more.
Hello, everybody. In this video, I'm going to explain variable arguments, also known as var args, in Java. Variable arguments allow a method to accept a varying number of arguments. They make methods more flexible, and there's no need for overloaded methods. Overloaded methods are methods that share the same name, but have different parameters. In this example, I have several add methods. They each have different amounts of parameters. If I was to add a few numbers together, for example, I'll add 1 plus 2 plus 3, well then I would use this method. What if I told you instead of creating several different methods that basically do the same thing, we could instead create one method that accepts any number of arguments? We'll only need to declare one method. We will create one add method that accepts a varying amount of arguments. So let's create a method. The return type, let's say, is an integer. We'll create a method of add. Our method will have one parameter. What is the data type of the values we're sending this method? In this case, integers. We're going to follow the data type with 3 dots, and ellipsis. How this works is that the Java compiler is going to pack the arguments we send it into an array. We'll need a name for this array. Let's say numbers. Just to demonstrate this temporarily, I'm going to print my array of numbers. When we call the add method, we can send any number of arguments. For example, 1, 2, 3, 4. And they're going to be packed into an array. Within this method, we're now working with an array. Let's perform a test run. Let's return void, actually. So we're given a memory address of this array. Now let's actually add these numbers together. We need to cycle through the elements of this array. We can use a for loop or an enhanced for loop for that. So let's return an integer in this case. Let's declare a local variable of sum. I will set that to be 0. Let's create an enhanced for loop. the data type will be int for every number in my array of numbers. Let's take our sum and add the current number. Sum plus equals number. Then at the end, we will return our sum. And there we go. And then we need to print the output. I'm going to cut this and paste it within a print statement. Let's perform a test run. The sum, when we add these four numbers, together, the sum is 10. And we can pass in any number of arguments. The result is now 21. Basically, the Java compiler is packing all of these arguments into an array when we send them to a method. Then within the context of this method, we would just need to work with this array, one way or another. But it's a lot easier than having several different overloaded methods. Okay, this time let's create a new method. We'll create a method of average. Average will find the average value of whatever we send it. So we will create a static method that's going to return a double this time. The method name will be average. What is the data type of what we're sending? Let's say double. Then we need the ellipsis, the 3 dots, then a unique name for this array. Let's say numbers. So to find the average, we can perform the following code. Let's say we have double, sum, numbers, add them together, points out this time array elements of a method array.
So you want to start a coding career? We can help with that. We're Codecademy, and we've taught millions of people the skills they need to reach their goals. It all starts with our interactive platform, where you get hands-on experience writing code right from day one. And with a Codecademy Pro membership, you get everything you need to land the job you want, like guided career paths, AI-powered practice, professional certifications, and code challenges to help you prep for interviews. Try Pro for free today.
Arrays in Java, also known as multidimensional arrays. A two-dimensional array is an array where each element is an array. It's useful for storing a matrix of data. Let me give you an example. Let's say we have some basic one-dimensional arrays. I will create a string array of fruits. Think of some fruit. I'll add an apple, an orange, and a banana. Then I'll create another separate array. Let's create a string array of vegetables. Think of some vegetables. I will add a potato, an onion, and a carrot. Let's create one more. I will create a string array of meats. I will add chicken, pork, beef. Let's add one more, and fish. These 3 arrays are all separate one-dimensional arrays. Well, what if I told you we can make an array made of arrays, where each element is an array? Here's how. We're going to combine all these arrays together.